If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Please share it with all others who might benefit. Let's get started. In this section, we begin our discussion with regular expressions. So first of all, what is a regular expression? A regular expression is a special sequence of characters that uses a search pattern to find a string or a set of strings. So while working on text data or a data which has some specific patterns that you want to extract from the data or you want to trace, the knowledge of regular expressions comes very handy. This essentially gives us some guidance around the patterns that may be interesting to find in a data, or might be the only interest at times as a researcher that you want to find out from a given data. For example, you might be given a huge paragraph of text and you might be interested only in extracting the phone numbers out of that, or just the email addresses out of that. That is possible using regular expressions. So its knowledge comes very handy if you're going to work on any kind of data which deals with text or patterns. It can detect presence or absence of a text by matching it with a particular pattern, and it can also split a pattern into one or more sub-patterns. For example, from a phone number, you might be just interested in extracting the area code. Regular expressions might work. From an email address, you might be just interested in extracting the domains. Regular expressions would come handy there as well. So Python provides an RE module which has a primary function that it offers search, which takes a regular expression and a string. So we generally import RE using just the syntax import RE, and that's the name of the module itself. RE is the name. It's not a short form. It's not like a Cborn is imported as SNS. The name of the module itself has been conveniently kept as RE, stands for regular expressions. So what are the uses of regular expressions? First is, of course, pattern matching. Regular expressions are, of course, used for extracting the specific patterns of interest from a given text. These are also used for text extraction. They can be used to extract some meaningful data. And let's say if you're interested in analyzing system logs, let's say the IP address activity and all, once again, regular expression would come handy there. They can also be used for text manipulation. So if you're working on a text data and you want to replace a particular pattern with something else, let's say a company has changed its email address and they want to assign a different domain. They want to leave the first part or the username part of it the same, but the domain only has to be replaced. Regular expressions would come handy there as well. Of course, regular expressions are used for data cleaning tasks as well, because if let's say you have a column which has a mix of numbers and some units associated with numbers, so Python in such cases would begin to treat that column as an object, would not be able to analyze the numbers separately. But with the help of regular expressions, we'll be able to eliminate the unwanted patterns and get the data in a format that's suitable for further analysis. So regular expressions are also used in programming and scripting. A lot of times the syntax checkers use regular expressions under the hood to give you feedback regarding potential errors with your code. So regular expressions are also popularly used for web scraping. Once again, you want to extract some specific information. Let's say you have a web page and you only want to extract some tabular information out of that page, not the entire text. You will be able to do that with the help of regular expressions. Now, what we'll do is that we'll talk about different components associated with regular expressions, starting with metacharacters, then we'll go to special sequences, and then we'll go to sets. What we'll do is we'll finish a list of, let's say, metacharacters, then we'll start with the usage of special sequences, then we'll do the hands-on piece, and we'll keep on alternating between these. Let's understand what are these metacharacters. So a pair of square brackets, it's said to be a set of characters. So when we say A-Z, it means it's going to search for a pattern which is anything between A to Z. Now, you'll get more clarity on this as we start implementing all of this. But as of now, A-Z basically gives you an entire range. Inclusive of A and Z, it could contain any lowercase alphabet. If we would have written 0-9, it would take any number from 0 to 9. The backslash is used as a special sequence. So if we write \D, it means that we are referring to a digit. If we write \lowercase s, it indicates a white space. Likewise, this dot or period essentially represents any character except new line character, single occurrence. So when we say HE.O, it indicates it could be any character except new line character. Not both the dots have to be same. So it could be alphabet, it could be number, it could be anything else, but it cannot be a \n, which is generally a new line character. This caret symbol that you see represents the beginning of a string. So if we search for a pattern, let's say caret good, it would find out those strings which start with good. Likewise, this dollar symbol represents the ends with. So if we write earth and dollar symbol, it will try to find out those strings that end with earth. When we talk about an asterisk, it represents 0 or more occurrences. So when we say HE dot asterisk O, first of all, this dot, as we know, could represent anything. So maybe it is, let's say, the alphabet L. So if we have HEL and then we put asterisk, what does it mean? This L may or may not be repeated. So it would essentially look for the preceding character. So if you have a repetition, let's say you have a word which is hello with 2 L's there, it will match that. Because whatever was the preceding character can be repeated. But if it just has HELO, that'll also work because it says 0 or more occurrences. So may or may not necessarily be repeated. So it could be any character which may or may not be repeated. So in case the character that's captured through the period is not occurring again, that's also fine because it allows 0 or more occurrences. Likewise, plus has 1 or more occurrences. So now in this case, whatever character you place at this period or full stop, that would at least have 1 more occurrence. Notice in both the cases, whether it's asterisk or plus, there is no limit to the number of repetitions. The only difference is when you have an asterisk, it would have 0 or more possibilities. So it could also have a pattern which is HEO if there is nothing that's represented by the period. But in case of plus, it will at least have 1 character because it talks about at least 1 occurrence. So it would never lead to a pattern which is HEO. It will at least have something between E and O. And there could be any number of occurrences of that character. Likewise, a question mark represents 0 or 1 occurrence. So there's a difference. Asterisk was 0 or more, so any number of occurrences. Plus was 1 or more, any number of occurrences. Question mark has 0 or 1. It would have either no occurrence or at most 1 occurrence. Likewise, these flower brackets or the curly brackets represent the exact specified number of occurrences. So when we say HE dot and we write in these curly brackets 2O, it means whatever is there is repeated exactly twice. If you write 1 there, we would have 1 written twice. If you write L there, that will be repeated twice. It is kind of limiting to a specific number of occurrences that you want to be repeated. Similarly, this pipe symbol here represents OR. So when we say hi and pipe hello, it could be either hi or hello. And the typical parentheses are essentially used for capturing the groups. So when, let's say, you're validating a phone number, it may be a collection of 3 digits separated by a hyphen, another 3 digits, and then hyphen and 4 digits, like the typical US numbers are. So while tracing such patterns, we may often be needing to capture the groups. Same logic applies for, let's say, tracing the IP addresses as well. Next, we move on to the hands-on piece related to metacharacters, where we'll see all of that we discussed here in action.